morning. Thank you for watching. So today I will be looking at two byte-oriented file register operations. And no, it's not this one. I'll be looking at RLNCF, rotate left file, no carry, and RRNCF, rotate right file, no carry. Alright, I won't cover much code unless it's necessary to understand these new instructions that I'm trying out. So at the beginning here, these equates are for the delay subroutine I've got at the end, and all this just sets up my chip so it works correctly. Port D is an output, port C and B are inputs. I begin by loading this value here into port D. As you can see, there's all ones on this side and zeros on this side. In binary, that's what it looks like. Here's the hex number, and I just learned that the decimal number is 240. It doesn't matter so much what those numbers are, so long as when it sits in a port, it looks like this, with all ones on this nibble and zeros on this nibble. Now there is another instruction called, what do they call that? Swap F. And what that does, it just swaps these 4 bits for these 4 bits, where you swap nibbles, but that's okay. For now, I'm just going to do it this way. So I begin by loading up port D with this binary number. I called this subroutine like my main code. I'm going to bit test RC0 in port C, which I set up as an input. So I have a push button on RC0, and I'm going to do the same thing with port B on RB0. So I have 2 push buttons. In the resting state, they're pull down lows, and when I press them, they get a high signal. So in the resting state, they're clear. Bit test F, skip if clear. If RC0 is clear, my finger is off the push button, it will skip this next line, and then it'll check B. If B is clear, it'll skip that next line and send it back to main. And it'll wait for me to push the RC0 push button I have hooked up, or the RB0 push button I have hooked up. Supposing I press RC0 and send it a high, then it won't skip if clear because it'll be high. So it'll go to the next instruction, which is go to, and I called it M left because I want everything to move left 1 bit at a time. So it'll go into this subroutine, RLNCF, port D, F. Once again, this RLNCF is rotate left, and you do that to a file with no carry. So I initialized port D to look like this, with all ones to the left, all zeros to the right. Running this instruction once will take all of these numbers and rotate everything left 1 bit location. So in effect it'll look like this. And I do that 4 times, and by doing that it rotates everything to the left 4 times, and the resting state, it should look like this, which is the opposite of what I initialized port D as. And then once it's run through there, it'll go to main. Supposing RC0 was clear, my finger is off that push button, and I push the push button connected to RB0, setting RB0 or making it high. Then it won't skip the next instruction. It'll go to M right. By M right, I just mean move right. And I won't re-explain this, but basically it takes that byte of information and starts shifting everything to the right 1 bit. I won't discuss the delay routine. I've covered that in some of my previous videos. And if none of the buttons are pressed, it just gets to the bottom of the code and iterates through. I'm waiting for one of these 2 buttons to be pressed. So now I will move on over to my breadboard setup and my experimenter's platform and show what I came up with.
Alright, so just to show you everything here, here's RC0, RB0, and they're both hooked up to these push buttons, which are powered by the experimenter's platform. Each push button is held low by a 10K resistor, here, here, and here, and there's a 220 ohm resistor on all of them, I think, to protect the input pins on the chip. So this one is RC0. It should shift everything left. I'm going to get the camera a little closer to where all the action is. So that shifts everything to the left. And when I push the RB0 push button, it should send everything back to the right. Now I can push this again and it'll send it to the right. Really, every press of a push button does a swap, no matter if I push the same push button twice or if I push the other push button. So I could have used the swap F instruction instead, but it wouldn't have been as cool and fun and awesome to watch on the breadboard. Anyway, thank you very much for watching.